HAC Code of Practice Clauses 2, 3 and 4. We must act ethically, give both best advice possible. Also advise when a hearing aid is not suitable. Hearing aid selection criteria: FAMOS, frequency response, acoustic gain, maximum output, other features, system configuration, size. Live Arga half gain rule, most common. POGO, prescription of gain and output. Sensory neural loss requires approximately 50% of their hearing loss in gain. Conductively impaired people need on average more gain than similarly impaired sensory neural loss. Gain must be sufficient to overcome the client's loss. It's vitally important that maximum output must not exceed the client's ULL level. Note, ULL is measured in dBHL, maximum output is measured in dBSPL. Difference between threshold of hearing and uncomfortable loudness level is the test subject's residual hearing or dynamic range. Threshold of hearing is the lowest level at which a positive response is achieved to the stimulus presented through a pure tone audiometer at a particular frequency in 50% of the presentations in ascending trials, minimum 2 out of 4 trials, in the average healthy human ear. This is 0 dBHL. Uncomfortable loudness level. Uncomfortable loudness level is the amount of sound pressure that causes an awareness of impending onset of physical discomfort. In the average healthy human ear, this is about 120 dBHL. The onset of pain is about 140. Annual calibration of an audiometer. Frequency to be within plus or minus 3% of the indicated frequency. Intensity. Absolute intensity should be according to the table of reference equivalent threshold sound pressure levels. All figures refer to TDH39 headphones calibrated to BS2497. For example, 0 dBHL at 1000 Hz using TDH39 headphones, the audiometer should produce a sound pressure of 7 dB SPL in a 6cc coupler. Attenuation: for each 5 dB step on the attenuator should not produce a change of not less than 4 dB and not more than 6 dB. Rise and fall times should be not less than 20 milliseconds and not more than 200 milliseconds. Spurious noise should be at least 50 dB below the pure tone intensity. Harmonic noise: any harmonics of the pure tone produced by an air conduction receiver should be at least 30 dB below the fundamental tone. Tone interrupter switches, other controls should be click-free. Considerations for an audiometric test room: ambient noise level of 30 dBA or less, reverberation time of 0.25 seconds or less. Reverberation time is the time taken for a sound to decay by 60 dB and is a measure of how acoustically dead the room is. Often warble tones are used for this. Presentation of test tone in audiometry should be randomly vary between durations of 1 and 3 seconds. This helps prevent the subject anticipating impending test stimuli. It also allows for the on effect and auditory adaptation. The on effect is the ear's initial most vigorous response to a stimulus and is followed by adaptation, where the response fades as the stimulus continues. In cases of overlong stimulus presentation, threshold may be adversely affected and audiometric accuracy compromised by the unwanted effects of adaptation. So-called occlusion effect can be as great as 20 dB enhancement at 250 Hz, falling to 5 dB or less at frequencies above 2000 Hz. Contralateralization can occur via bone conduction testing at any intensity or during air conduction testing at intensities of 40 dBHL or more. Masking in audiometry is the blotting out of one cochlear response whilst testing the opposite ear in isolation. It's also a masking rule which states that the threshold for hearing one sound can be raised by the introduction of another different sound. Speech audiometry tells you how the ear responds to complex tones of speech. Speech audiometry: calibrate the equipment using the 1000 Hz reference tone from the tape or disc. Loudspeakers to be used in free field conditions, then 60 dBA must be delivered to the point at which the test subject will be listening. Set audiometer output to give approximately 50% repeated correctly score. Present a phonetically balanced word list. Record the number of words repeated correctly as a percentage on the speech audiogram. Increase output by 5 dB until 100% correct score is achieved. Comparison of subject's own articulation curve with previously plotted normal articulation curve. Middle ear acoustic impedance. This describes its resistance to the passage of sound, SOS. Off system produces uniquely identifiable tympanograms. Objective test and very quick. Good for testing children for glue ear. Measures the sound energy reflected by the probe microphone. Measurements conducted at varying positive and negative pressures. Purpose is to determine at what meatal air pressure the maximum amount of sound energy is transmitted through the middle ear. Dependent on whether this is less than, greater than or equal to normal will determine the relative compliance or impedance of the middle ear. Tympanometer can also measure acoustic reflex. This can be a diagnostic indication of retrocochlear dysfunction. Pressure is equalized and allowed stimulus of 80 dB SPL or 70 dB above threshold introduced via the probe. This is increased in 5 dB steps until reflex occurs. If there's no reflex, it could be a conductive loss of greater than 15 dB, the lesion, tumour or cranial nerve 8 loss of efferent transmission to brain from cochlea, a tumour of cranial nerve 7 loss of efferent transmission from brain to stapedius muscle. Tympanometer can also be used for acoustic reflex decay, measurement of the duration of time for which a subject can maintain his acoustic reflex, also an indicator of retrocochlear dysfunction. Establish the acoustic reflex as previous, add 10 dB to the sound pressure used, and play the tone continuously over a 60-second period. Normal ear will maintain reflex over the full 60 seconds. If neuroma is present, there will be a 50% decrease in the acoustic reflex within 10 seconds. Tympanometry only measures middle ear. Objective tests for middle ear, but new objective tests for the cochlea have now been developed. Electrocochleography, ECOG-G, records electrical activity of the cochlea and first-order 8th nerve fibers in response to acoustic stimulation. Electrode played against the promontory under anaesthetic. Click stimuli are used to evoke any cochlear response, which is recorded as electrical activity from the cochlea. Auditory brainstem response records the various potentials of the cochlear nerves, brainstem and cortex in response to acoustic stimulation. Electrodes placed on the scalp record any neural activity some 10 milliseconds after the acoustic stimulus. Electrodermal response, psychogalvanic. This is semi-objective, which tests his condition to receive a small electric shock at the same time as he perceives a pure tone stimulus. As a reflex protection to the electric shock, the subject becomes conditioned to alter the conductivity of his skin every time he hears a tone. Change in conductivity of skin is then measured as a response to pure tone stimuli. Otoacoustic emission testing. Detection of minute acoustic emissions produced by cochlear hair cells in response to incoming acoustic stimuli. Poems, programmable otoacoustic emission system. Utilizes the concept of detecting evoked otoacoustic emissions as an objective audiometric test. Click generation system, acoustic stimuli, ear canal probe housing acoustic output, transducer and probe microphone plus a vent tube. Preamplifier filter circuits, computer systems to separate the evoked acoustic emissions from reflected input stimuli and display data. Loudness recruitment. Recruitment is that condition where a small increase in the objective intensity of a sound produces an abnormally large increase in the sufferer's sensation of loudness. Only present in disorders of the cochlea, thought to be brought about as a result of outer hair cell damage. 2 tests for testing loudness recruitment. 1. Fowler's alternate binaural loudness balance test for use in unilateral losses. 2. Monaural bifrequency analysis, which can be used where both ears are affected. The CC test has also been used. Fowler's alternate binaural loudness balance test relies on balancing the sensation of loudness in a subject's bad ear with the sensation of loudness in his other normally hearing ear. It can only be done on a twin-channel audiometer. Subject asked to compare sensation of loudness in each ear from 2 different frequencies, increased in 5 dB steps. If the other ear requires the same amount of 5 dB steps, there is no recruitment. If the bad ear needs a larger increase, then it could be recruitment. Monaural bifrequency recruitment test. Most significant differences in hearing loss between the high and low frequencies, such as in ski slope loss. Subject asked to compare loudness of 4000 Hz and 500 Hz in the same ear. Intensity raised in the 4000 Hz. Subject asked by how much the lower tone has to be increased to equalize. If in the instance a 5 dB increase in intensity at 4000 Hz requires a 10 dB increase of 500 Hz to sound equally loud, this would imply that a small increase in objective intensity at 4000 Hz is creating an abnormally large increase in the sufferer's sensation of loudness, hence recruitment has taken place. CC, Short Increment Sensitivity Index, designed to highlight a heightened ability to detect small increases 1 dB in intensity over and above a continuous audible signal. When the audiometer is set to CC, the test mode, the audiometer will automatically present a tone 1 dB greater than the continuous tone every 5 seconds for a duration of 0.2 seconds for each burst. The test is continued for 20 blips, with the subject indicating each blip heard. Cumulative score is recorded as a percentage, 0 to 20% blips heard, normal hearing, conductive loss or retrocochlear loss, 60 to 100% blips heard, cochlear-based hearing loss indicated. Non-organic hearing loss, psychogenic loss, malingering. Test to carry out a malingerer, add audiogram, serial, Doppler-Stewart test, delay playback test. Tone decay adaptation test. Adaptation is a phenomenon which characterises all sensory systems. It can be defined as a shift of threshold brought about by continued stimulation with the same stimulus as was used to determine the threshold. Some retrocochlear conditions produce an abnormally severe degree of auditory adaptation at quite low intensities. This could be symptomatic of 8th nerve disorders. Tone decay test. The tone remains audible for 60 seconds. There is no tone decay. If less than this, the intensity is increased until the subject can hear it for a full 60 seconds. The difference between this and the original is the degree of tone decay. There is a clear relationship between frequency, wavelength and velocity, e.g. frequency equals the number of complete cycles in 1 second, wavelength equals the distance travelled in 1 cycle. Therefore the distance travelled in 1 second is frequency times wavelength equals velocity. Sound pressure can be measured in pascals. The smallest change in sound pressure detectable by the average healthy human ear is 0.402 pascals. To convert sound pressure pascals into decibels, the following formula. Sound pressure in dB equals 20 times log 10 times P1 over PO, where P1 is the sound pressure measured, PO is the reference pressure. Concha behaves as a half wavelength cavity, resonant frequency 7000 Hz. External auditory mesos behaves as a quarter wavelength tube, resonant frequency 3500 Hz. An analog is an exact copy of the amplitude and frequency of the sound wave, but in a different medium. D-class receivers have 1. Power amplifier built into it. 2. Switched output stage. Current is only drawn when the switch is closed. 3. Extended battery life. 4. Enhanced high frequency response. D-class receiver, O-disc saw, oscillator, divider, integrator, signal adder, comparator, Schmitt trigger, switch driving amp, output amp, receiver. Advantages: increased output levels, longer battery life, high frequency output, reduced number of components, smaller space required, great circuit reliability. Disadvantages: circuit noise at low frequency, sound may be too sharp for some people. Occluded ear simulator, Zwislocki coupler. Ear simulator, device for measuring the output sound pressure of an earphone under well-defined loading conditions in a specified frequency range, consists essentially of a principal cavity, acoustic load networks, and a calibrated microphone. Location of microphone is chosen so that the sound pressure at the microphone corresponds approximately to the sound pressure existing at the human eardrum. It has 4 adjustable side resonators. Don't get artificial ear mixed up with occluded ear simulator, 2 different things. Artificial ear is a device for loading an earphone with an acoustic impedance which simulates that of the average human ear, used for measuring the sound pressure thus developed. Fitted with a 6cc coupler, it's used to calibrate an audiometer in its AC headphones. An artificial mastoid device for loading a bone vibrator with a mechanical impedance which simulates that of the average human mastoid, measures the vibration so produced. Can be used to reproduce frequency response charts for a bone conduction hearing aid, or to calibrate an audiometer and its bone conduction unit. Sound level meter, a reference scale, special weighted scale, high and low pass filters. Reference level of the A scale is the human equal loudness contour for hearing faint sounds. Symptoms of sensorineural loss. Sufferer hears worse in background noise. He tends to shout, cannot hear his own voice properly, complains of poor discrimination, one word runs into another, An increase in volume will not necessarily improve clarity. He hears some sounds better than others, male voices better than female, low frequency better than high frequency. Symptoms of conductive loss. Sufferer hears better in background noise, paracusis. Sufferer tends to talk quietly, hears his own voice very well by bone conduction, but is less aware of ambient noise by air conduction. An increase in volume will improve clarity. Sufferer may present typical outer or middle ear medical symptoms. Under bacterial forms of hearing loss, chronic middle ear infection may lead to infection of the inner ear, otitic labyrinthitis, due to the spread of infection through bone or via the vascular system. Mastoiditis, with the resultant risk of bacterial meningitis, may also result. Under neoplastic, a benign eighth nerve tumour known as vestibulocochlear schwannoma or acoustic pneumoma causes a slow unilateral sensorineural hearing loss, often accompanied by vertigo and tinnitus. Under metabolic, hormonal, as well as diabetes, you could have myxedemia, which is swelling of the endoderm affecting middle or inner ears. Non-hormonal, as well as dyslipidemia, you could have kidney failure. Autoimmune disorder, as well as AIDS, you could have Wegener's granulomatosis, causes conductive loss due to bone lesions. Polyarteris nodosa constricts the blood supply due to the disease of the arterial or sensorineural.